Washington believed it had found the pressure point, cut China off from the world's most powerful AI chips, and its race for artificial intelligence would slow. For a time it did. But the blockade also triggered something more dangerous, an emergency campaign to build an entirely separate AI machine. Today, inside Chinese data centers, thousands of domestic processors are being wired together to do work. Once reserved for NVIDIA, they are not as efficient. Their software is not as mature, but they do not need permission from Washington. And if China succeeds, the world may not have one AI ecosystem. It may have two. This is not a story about one miraculous Chinese chip defeating NVIDIA. That has not happened. It is the story of how a technological blockade can become an industrial alarm clock, and how Huawei is trying to turn political isolation into a new kind of power. To understand the stakes, begin with NVIDIA's real advantage. It is tempting to imagine the company as a factory that sells extraordinarily fast processors. But NVIDIA owns no leading-edge fabrication plants. Its empire is a stack: GPU architecture, CUDA software, networking, libraries, developer tools, and complete data center systems. Millions of engineers have spent years learning how to make that stack work. CUDA is the invisible wall around the kingdom. A rival chip can look impressive on a specification sheet and still lose in the real world because researchers need stable compilers, optimized libraries, and software that does not collapse halfway through a month-long training run. NVIDIA does not merely sell computing power. It sells time. And in the AI race, time may be the most expensive resource of all. By fiscal 2026, NVIDIA's annual data center revenue had reached nearly $194 billion. The company was no longer simply participating in the AI boom. It had become its essential infrastructure. American officials also saw the same processors as strategic technology, machines capable of training powerful models, analyzing surveillance data, and accelerating military research. In October 2022, the United States introduced sweeping controls on advanced computing chips and semiconductor manufacturing equipment bound for China. The rules evolved again and again. They targeted performance thresholds, supercomputer uses, chip-making tools, and eventually certain high-bandwidth memory, the ultra-fast memory needed to keep AI processors fed with data. The objective was straightforward: increase the cost and time required for China to build frontier AI systems. Yet the policy created a strange loop. Every new restriction reduced China's access to American technology. But every new restriction also made Chinese self-reliance more urgent, more profitable, and more politically important. NVIDIA tried to adapt. It designed reduced performance products for the Chinese market, including the H20. Then the regulatory ground shifted again. In its fiscal 2026 filing, NVIDIA said it had been effectively shut out of China's data center compute market under the existing environment. The company recorded a $4.5 billion charge linked to H20 inventory and purchase commitments. The rules changed once more in January 2026. The United States said applications for chips, such as NVIDIA's H200, could be reviewed case by case if strict conditions were met. This was not a simple wall. It was a gate that could open, close, or narrow with politics. For Chinese technology companies, that uncertainty became a risk almost as serious as the restriction itself. Imagine building a power station without knowing whether fuel will be available next year. Even if imported chips remain faster, a domestic chip with guaranteed supply can become strategically valuable. That calculation pushed Beijing, cloud companies, and local developers toward Huawei. Huawei entered the crisis with scars. Washington had already placed the company under severe technology restrictions years earlier. Its smartphone business lost access to critical components, and many observers expected the company to retreat. Instead, Huawei increased research spending, rebuilt supply relationships, and placed computing at the center of its recovery. In 2025, Huawei reported spending more than 192 billion yuan on research and development, over 1/5 of its revenue. The company was not trying to copy one NVIDIA product. It was assembling its own stack, Ascend processors can software, servers, networking, cloud services, and developer tools. Its most dramatic answer is not a single chip. It is scale. Huawei's Atlas 900A3 SuperPD connects as many as 384 Ascend 910C processors and presents them as one logical machine. The approach is brutally practical. If one domestic processor cannot match NVIDIA's best silicon, connect many more processors together and attack the bottleneck with networking, system design, and electricity. Huawei says these 384 processor systems have already been deployed in industries including telecommunications, finance, electric power, and internet services. Its annual report counted 4 million Ascend developers and thousands of ecosystem partners. Those are company-reported figures, but they reveal the strategy. Hardware is only the entrance. The real objective is to create a software ecosystem that Chinese companies cannot easily leave. This is where the contest becomes more complicated than benchmark charts. A SuperPD can deliver enormous total computing power while consuming more chips, more power and more space than an equivalent cutting-edge NVIDIA system. Connecting hundreds of processors also creates a traffic problem. Data must move between chips fast enough that expensive hardware is not sitting idle. Then there's memory. Modern AI accelerators depend on high-bandwidth memory placed close to the processor. HBM is difficult to manufacture and tightly connected to advanced packaging. China can design increasingly capable AI processors, but producing them reliably and feeding them with enough fast memory remains a major constraint. Fabrication is another wall. The most advanced chips require an orchestra of lithography, deposition, etching, inspection, and design tools. Many of those tools are controlled by companies in the United States, Japan, and Europe. Chinese fabs have demonstrated surprising progress, but leading-edge production can involve lower yields, higher costs, and more complex workarounds. And software remains NVIDIA's deepest moat. Porting an AI model from CUDA to another platform is not like changing a phone charger. Custom operations may have to be rewritten. Performance must be tuned. Bugs appear in places that worked perfectly before. A chip that is available but difficult to program can still waste months of engineering time. Huawei understands this. Its roadmap promises new Ascend generations, faster interconnects, and support for more numerical formats. It is also opening more of its software stack and recruiting developers. These are targets announced by Huawei, not proof that NVIDIA has been caught, but they show that the contest is moving from isolated products to complete platforms. That shift creates an uncomfortable possibility for America. Export controls may preserve the West's lead in the most advanced systems while simultaneously guaranteeing a huge protected market for Chinese competitors. Before the restrictions, a Chinese cloud company could simply buy NVIDIA. Now, it has a strategic reason to fund the alternative, even when the alternative is slower. For NVIDIA, the immediate financial damage is survivable. Demand outside China is enormous. But the long-term risk is not merely lost chip sales. It is lost developers. Every engineer trained on Ascend, every model optimized for CAN, and every data center designed around a Chinese interconnect makes the parallel ecosystem harder to reverse. For China, independence also has a price. More hardware means more capital. Lower efficiency means more electricity. Fragmented domestic platforms can divide developer attention. And an ecosystem protected from foreign competition may grow large without becoming globally competitive. So who is winning? The honest answer is that the blockade is doing two things at once. It is making frontier computing harder and more expensive for China today. And it is accelerating China's determination to remove that vulnerability tomorrow. The result may not be a clean victory for either side. It may be a technological split, one world built around NVIDIA, CUDA, and allied supply chains, another built around Huawei, Ascend, and a heavily subsidized domestic network. Models may be optimized differently. Data centers may use incompatible systems. Governments may pressure countries to choose. The AI race was once described as a competition to build the smartest model. It is becoming something larger, a struggle over who controls the factories, memory, electricity, software, and machines beneath every answer an AI produces. Washington tried to use NVIDIA's dominance as leverage. China responded by treating dependence itself as the enemy. The Chinese system is still behind at the frontier, and its weaknesses are real. But it is becoming larger, more complete, and more difficult to stop. The question is no longer whether China can buy NVIDIA's best chip. The question is whether, one day, it will still want to.